In this video, I will discuss separation techniques of mixtures. First, I will discuss how to separate heterogeneous mixtures. These techniques include decanting, magnetization, and filtration. And then, I will talk about how to separate homogeneous mixtures. These techniques include chromatography, distillation, centrifugation, and crystallization. The first separation technique is decanting. This technique makes use of differences in density to separate immiscible or heterogeneous mixtures. For example, water and sand, oil and water, and ice in water, all of which are heterogeneous mixtures. For example, here we have water sitting on top of the sand, and basically you pour the mixture into a collection container, in this case a beaker, and you let it run along the glass rod to prevent splashing. So you're left with water in one beaker and sand in the other one. The next separation technique is magnetization. Here we use a magnet to collect magnetic samples and leave behind non-magnetic samples. For example, we can separate iron from sulfur. We can have a heterogeneous mixture of iron and sulfur, and we can grab a magnet, and the magnet in close proximity to this mixture will attract the iron because it's magnetic. So we can separate the iron fillings from the sulfur. And in general, we can have a powder that has a mixture of magnetic and non-magnetic material, and have a container that is magnetic and one that is non-magnetic, and the magnetic will always attract the material that is magnetic, so you can separate easily. The next technique is filtration. In this case, this technique is used to separate substances when there is a difference in solubility. For example, we can separate sugar from sand. We know that sugar can dissolve in water, sand cannot. So if we mix water with sugar and sand, the sugar will be dissolved in the water, so we can pour the solution inside a funnel with this filter paper. The filter paper has micron-sized pores that allows water to go through, but does not allow the big particles to go through. So you're left with residue solid trapped in the filter paper, and the liquid passes through it into the collection beaker. So in this case, the sand will be trapped in the filter paper, and the liquid with the sugar dissolved in it will go through the paper, and you separate sugar from sand. Also, you can separate immiscible particles in some solution. For example, big particles in water, you just pass it through the filter, and the particles will be trapped in the filter paper and water will go through. The next separation technique is chromatography. Chromatography relies on the abilities of the substances to absorb or stick to surfaces. For example, we can separate ink or dye components. As an example, imagine you have a piece of chromatography paper and we put an ink spot at the very end. Then we immerse the end of the paper into a solvent such as water, and the water will wet the paper and it will move up the paper. So the solvent will carry with it the ink spot, but the components will move up at different rates. The components that are higher and move with the water are the ones that are dissolved more easily into water and absorbed less by the paper. And the ones that are lower are the ones that are absorbed better by the surface of the paper and they dissolve less easily in water. As a result, we can come up with an RF ratio which is A over B, and A is the distance of how far the solvent moves, in this case water, and B is how far the ink component moves. So an RF distance close to 1 are the ones that move farther with the water. So these components are easily dissolved in water and do not absorb to the surface too well. And RF components that approach infinity are the ones that do not dissolve too well in water and absorb well to the surface. The next separation technique is distillation. This technique makes use of differences in boiling points to separate homogeneous mixtures. For example, you can remove water from dissolved salt. Imagine that you have salt here, particles of salt, and I'm exaggerating the sizes, but they are homogeneously dissolved in the water. So salt in water. Then we know that the boiling point of the salt is greater than the boiling point of water, which is 100 degrees Celsius. So if we heat it up to a temperature greater than 100 degrees Celsius, then the water will vaporize and travel up this column. And then it will go into this condenser, which is cooled down by cold water. So the temperature in this condenser is much less than the boiling point of water. So the water vapor will condense back into liquid and be collected into this flask. So here we have water, and because this temperature is less than the boiling point of the salt, then when we cool down this after vaporizing all the water, then you will have only the salt left over here, thus separating salt from the water. The next separation technique is centrifugation. We can use centrifugation to settle solid particles to the bottom of a solution by spinning it at pretty high speeds. For example, we can separate blood cells from blood plasma. In this figure, we have a sample of whole blood, and we can place it in one of the slots of the centrifugation machine. We have to also put another sample of similar mass in opposite direction to the first sample so that it can counterbalance the machine. In a similar way, we can put more pairs of samples. Then we can spin it at speeds greater than 300 revolutions per minute, or RPM, and as a result we get at the bottom erythrocytes, which are hemoglobins or red blood cells, which are used to transport carbon dioxide and oxygen into and out of tissue. A certain percentage of these hemoglobins tells you whether someone is healthy. And then on the top we get plasma of blood. The next separation technique is crystallization. Crystallization is a process that uses the sun to evaporate salt from brines. Brines are supersaturated solutions which contain as much salt as a solvent can dissolve. For example, we can get lithium salts from brines in the lakes of Bolivia. The lithium salts are supersaturating the water in the lakes. So, when the sun is used to evaporate the water, we can get salt from here by crystallization.